In this video, I will be walking you through how to do a full mathematical analysis for the linear relationship we've drawn from this data. In other words, we are going to create a mathematical model, an equation, which describes this line of best fit using the 2 points we've identified on the line to calculate the slope. My first step is to grab a new piece of paper. I am never going to do a mathematical analysis on the graph itself. This should always be off to the side. After that, I'm going to identify some variables. On my horizontal axis, I have time. So I'm going to write the word time, and then identify its variable, which will be a lowercase t. Not S for seconds, that's the unit. The thing I'm measuring, the physical quantity, is time, whose variable is t. I'm going to do the same thing now for what's on the vertical axis. I have position as my physical quantity on the vertical axis, so I'm going to write the word position. And the variable we use in physics for a horizontal position is an x with a vector arrow above it. So that's our position. From there, I'm going to identify the equation y equals slope times x plus b for a linear relationship because I do have a line. But now I'm going to replace the letters y and x with my variables that are on those axes. On the y-axis, I have position, so I'll replace the letter y with my vector position x. I'll leave the word slope alone. On my x-axis, I have time, so I'll replace the letter x with the letter t, and I'll leave plus b for the y-intercept. I will now go through and do a slope calculation. In general, a slope is computed as delta y over delta x. In this case, my y-axis is position, so I'm going to do delta position divided by delta t for delta time because time is on my x-axis. So change in y over change in y-axis over change in x-axis. From here, I'm going to remind myself that that delta means do position 2 minus position 1 divided by time 2 minus time 1. Now and only now am I ready to plug in numbers. And so I'll go back to the point I've identified on my slope. Let this be point 2, or sorry, on my line, this will be point 2. Its position is over here at 0.35 meters. Minus, I'll let this be 0.1, and its position is negative 0.05 meters. So minus negative 0.05 meters. And we'll divide that by T2. Going down now, I am at 1.4, here's 1.5. What is this? So this is, each of these is 2/3, 4/3, 6/3. So this is, I should have done this ahead of time. Give me just a second. This is 2.07 is where that is. So sorry, 1 point. Oh, now I'm confused. This should be 1.57. 1.57 seconds minus, I chose a confusing scale. That's my bad. Here, 0.8. That should be 4.7? No, that should be 5.7. 5.3, my bad. That should be 0.53 seconds here. And this one should be 0.8. Plus that should be 0.93 seconds there. Great, and now I have my slope calculation. Notice how all 4 of my numbers have their units. Position 2 isn't just 0.35, but 0.35 meters. Position 1 isn't just negative 0.05, but negative 0.05 meters. Similarly, time 2 has its units of seconds, and time 1 has its units of seconds. After that, I can go ahead and do all of the math in my calculator. Give me a second to grab my calculator and do that. When I do 0.35 minus a negative 0.05, and I divide that by the quantity 1.53 minus 0.93, I end up with exactly 0.5. 0.50. It's crazy that I came out that clean, actually. Oh, that's because I typed something in wrong. 0.67 is what it actually comes out to be. That's my bad. 0.67. And my units on that are meters in the numerator and seconds in the denominator. And so that is the slope value I have, 0.67 meters per second. From here, I can identify what number value my y-intercept is. I go on my graph and I notice that this line hits the y-axis between negative 0.65 and negative 0.70, and it's closer to the negative 0.65 end of the spectrum here, so I'm going to call that negative 0.67. Negative 0.67 meters is my y-intercept. And now I'm going to go back up here to my line equation, and I'm going to replace the word slope with negative 0.67 meters per second, and I'm going to replace the y-intercept variable b with its value, negative 0.67 meters. And so when I do that, I end up with my position being equal to slope 0.67 meters per second. I bring the variable t along. Don't forget that to multiply by the variable t. Folks often forget that. And then my y-intercept is negative, so I'll make that minus 0.67 meters. This is a full mathematical model which describes this line. So this is the equation which describes this line here. Our position is equal to positive 0.67 meters per second multiplied by the time variable, and then minus 0.67 meters. This y-intercept is our starting position, and this tells us, well, it's something meters per second. Let's think about that. And there we have it, a full mathematical analysis for our graph that we created from our data.